Now that we have already discussed the VCG mechanism in the combinatorial allocations in the previous module, let us look at this combinatorial auction in a little more detail. So what is the setup here? We have a set of objects, let's say M objects, and we have a possible set of bundles which is a power set of that M. So we are collecting together all the subsets of this set M, including the empty set and the complete set. So that gives rise to the set of bundles that a player can have. And we are going to assume that the type is now a mapping from that set of bundles to the set of real numbers. Exactly same as what we have discussed in the previous example. Every player is going to give a valuation associated with every bundle. So if they are given object 1 alone, what is the valuation? If they are given object 1 and 2 together, what is the valuation? And if there are more objects, what is the valuation over all possible bundles of those objects? And this is what we are going to mention as the type or the value of this player. And we are also going to assume that these values are all non-negative. That means we are only considering this objects that are goods. So the other thing would have been bads. So maybe if there are some objects which incur some cost for you, that would have been considered as bads, because if you are given that object or that bundle, your utility or your valuation would have been negative. But we are ignoring that for a while. So here we are only considering the combinatorial allocation of goods. Now we can define the allocation in the following way. We can say that an allocation is a partition of all these objects. And while we are defining this partition, this allocation we are going to define as A0 to AN, and this is here A1 to AN is the allocation to each of these agents, N agents, who are getting this object. So their allocation is a subset of this set M, and they are also disjoint subsets, and collectively they exhaust the whole set of objects, where the interpretation of this A0 is the unallocated objects. So if there are certain objects which are not allocated, they fall in this A0 category. And we are going to assume that the set A, which contains all such allocations. And quite naturally, we are going to assume if the allocation to a specific agent is empty, then he is getting a 0 valuation. The other term that we will use, also available in the literature, is called the selfish valuations. That even though there is an allocation, so this allocation is nothing but a collection of all these things, so A0 to AN, so A1 and AN, a particular player I is only worried about the ith allocation, the allocation that has happened to this particular agent. It's not worried about what is happening to the other players, and that is why it is called the selfish valuation. And that is what we're going to also assume. There is no kind of a dependency of the types with other players' allocations. So let us look at some of the properties that the VCG payment satisfies in this context. The first property that we are going to consider is the payment. So we have already seen this in a different example. Now we are going to make it a little formal. So in the allocation of these goods, when you are considering the VCG payment for these agents, if a particular player does not get any object, then the payment will also be equal to 0. So why is this true? We are just going to give a brief sketch. You can prove it in multiple ways. The idea is that when you are picking the efficient allocation under this VCG mechanism, it is so the assumption here is that player I is not getting any object, is getting an empty bundle, and we are also going to use this notation A minus I star to mean the efficient allocation or the social welfare maximizing allocation without agent I with this notation. and that is exactly equal to the argmax when you are considering all the agents except agent I. Now we already know that the VCG payment is always non-negative, right? Now we are going to write the same expression where you have this is the first term, so this is exactly putting it here, just that we have replaced the allocation, this a minus I star, which we already know is the allocation that maximizes the sum of the valuations except agent I when agent I is absent. And this is the sum of the valuations of all the players in the presence of agent I, but we are just taking the sum of the values of all the players except agent I. Now we are going to add two terms, both of which are actually equal to 0. So if you consider the valuation of agent I when agent I is not present, so in that case agent I is not going to get allocated any object, so quite naturally that valuation will be equal to 0. And also the valuation in the efficient allocation. Now we know that in the efficient allocation agent I was not allocated any object. That was the starting assumption here. So therefore by our assumption that if someone gets a 0 bundle, the empty bundle, then the valuation is going to be equal to 0. So that so we are adding this term in the second case, and the first term, that is this in the first term, and that makes it the sum over all j in n. Now this term we already know, so this is by definition is the maximum because of the definition of a star. Whenever you are taking the sum of the valuation of all the players, a star maximizes it. So this expression, this difference is always going to be less than or equal to 0 by the definition of a star. Now what we have seen is that this pi VCG was already non-negative. Now we are also proving that this is non-positive. So the only choice that is left is this VCG payment for player I is going to be equal to 0. That essentially proves the claim. So now let us look at a different property which we are going to call individual rationality. This is also called the constraint for participation. In some cases we'll also refer to this as participation constraint. So what does this mean? We are going to call a mechanism f comma p to be individually rational if for every type theta and for every player the utility of this player is going to be non-negative. So what it means is that by participating in this mechanism, which picks the allocation rule as f and the payment rule as p, nobody is getting any negative payoff. By participating in it, you are not going to lose. So put in the context of object allocation, if you are allocated some object, a bundle, the valuation of that bundle will always be larger than the payment that you are being charged. If that is the case, then we are going to call that mechanism to be individually rational. So there is no reason for any agent, any rational agent, not to participate in this game, because the net payoff can only be positive or 0, but which is weakly better than not participating. So here in this context we are going to show another claim. So in the allocation of goods, the VCG mechanism is individually rational. So this is another property that VCG satisfies. So why is this true? So let's say we are looking at the utility of player I. We have the PI of VCG, payment of VCG. Now the rest of the thing is just standard substitution of this thing of the payments. So what we finally get is the social welfare here at a star minus the social welfare except agent I. Now with that expression we are going to add and subtract one term, which is the theta I of a minus I star. So this is the utility of player I when he is not present. So that when we look at this term here, we club these two terms together to get this sum here, and the last term is going to be staying separately. So now let us look at these two terms together. So this is the social welfare at A star, and this is the social welfare at A minus I star, the social welfare without agent I being present. Now by definition of A star, this is going to be non-negative, and we have also assumed that the objects are actually goods. So the valuation for any player is also going to be non-negative. It cannot be negative in this context. So therefore together this valuation of a player I is going to be always non-negative, and because we have chosen this type and the player to be arbitrary, then it applies to all theta and all I. So therefore this mechanism, the VCG mechanism, is essentially individually rational. Note that this is only a sufficiency theorem. What it says is that in the allocation of goods, the VCG mechanism is individually rational. So there could be some other cases also, some other kind of allocations, in which case VCG mechanism can also be individually rational. But this is not saying the converse, that it is individually rational only if it is allocation of goods. In general, VCG mechanism can be non-individually rational in some settings, and that's why we are actually giving the sufficiency results for certain setups.